Thanks, everyone. I'm going to update you on some work we did last summer, and I gave a talk about some preliminary results we had last fall. But there's a few new results I wanted to let you know about. And it's a great project we did studying the effect of fans on heat stress in a manufacturing environment. We collaborated with colleagues in Australia at the University of Sydney, as well as colleagues in Singapore. The project was a 6-week field study in Baton Rouge, Louisiana, and we looked at the impact of running fans in a very hot environment in a factory where they're producing HVAC equipment. We had 30 workers in 2 different buildings, and we had the fans on half the time, off half the time, and we collected physiological, environmental data, survey data. All this was made possible by funding from Big Ass Fans and CB Partners. This is a view looking inside one of the buildings. You can see it's a large, tall space with a lot of different activities going on, anything from mechanical assembly to welding, all kinds of different of activities. There are fans both in the ceiling and along the walls that provided a lot of air motion. And so we were able to control those, turn those on and off at different times of the day. We divided each day into morning and afternoon sessions. The fans were on for half the day, either on in the morning or in the afternoon, and we'd switch that back and forth while we were collecting core temperature with a thermometer, just a oral under the tongue temperature, heart rate monitors, and we measured sweat rate, which I'm not going to go into in detail. I talked a little bit about that in October. You can come and ask me about it if you're interested in that specifically. We did surveys. You can see Hui out here taking some of his temperature and having them fill out a survey during the day, and we're also monitoring all the conditions in the space continuously. To give you a sense of what the conditions are like, the blue at the bottom is the outdoor temperature. You can see in the blue dot in the middle is the kind of average during the day. So the temperature is ranging up into the mid-90s, average temperatures in the high 80s. The red dot is the maximum indoor temperature, which you can see is quite a bit hotter than outside with all the activities going on in the space and the solar gain through the roof. So those are typically in the high 90s, reaching even 100 degrees Fahrenheit. And then the purple on the top is the mean radiant temperature peak. These are metal roof buildings, so you get a lot of sun beating down the roof, and so the radiant temperature can be quite high. So these are pretty hot conditions to be working in, just to give you that sense. Patrick and Jake, who are grad students, help with the analysis, are going to cringe right now as I show you this graph, because this is some results of this data from the survey data we did asking people about their thermal sensation compared with the temperature. There's a lot of statistics, a lot of data behind this graph, and I've kind of cartooned it here with just the crude results. But you can see the relationship between indoor temperature and thermal sensation. No surprise there. It's just as it gets hotter, people feel hotter, and this is the conditions with the fan off. When we're running the fan, you can see a dramatic reduction in their thermal sensation. It's about 1 volt. So people are going from hot to warm, or warm to slightly warm, or slightly warm to neutral. But a more interesting way to look at that, which we were interested in, if we consider a condition where we have the fan running, and we have in this case, we're at about 90 degrees Fahrenheit, and we look at their thermal sensation, if we want to ask the question, how much would we have to cool the space to get the equivalent thermal sensation? So we have to move left on that graph to get that same vote without the fans running. You can see that's a 10 degree Fahrenheit cooling, or 5 degrees C, right? So that's a lot of air conditioning that you would have to do to cool the space down to that equivalent cooling from the fan. So it's a huge benefit that these are providing. And of course, fans are going to do that in a much more energy efficient way than trying to air condition a space with all these large openings, not very well insulated. Very challenging space to air condition. Just to recap a little bit on the preference of the occupants, everyone wanted air motion. These are both with the fan on and fan off. We're asking if they would like more air motion. With the fan off, over 90% of the people want more air motion. Nobody wants less air motion. Even with the fan on, people would still like more air motion. No one's asking for less, even with these fans blowing. And I should say the fans in some places they're blowing a lot of air. The measured values there were anywhere from 0.5 meters per second up to 4 meters per second, which is a pretty good breeze. That's like putting your hand out the window of your car driving in the street. Everyone felt very strongly that the fans were important to have running. You can see either strongly agreed or agreed with the importance of having those in their workplace. And everyone, like 80% of the people approximately, thought it was made their jobs more effective. So they're more effective at getting their work done with these fans running. So it's really playing an important role, not to discount Toby's work, but we're operating in much higher conditions here than the conditions that Toby's looking at in the chamber, right? So these are clearly outside of that inverted U, or the adaptability range that Toby was referring to. We're going to have a session on, and we're not going to have a session on heat today, so I won't say that, but we are writing a paper that we're going to be presenting at a conference, the Comfort at the Extremes conference in Tucson, so we'll have that available later this spring on their website. So enjoy lunch. Thanks for your attention this morning, and David's going to have a few words for you. Yeah.